Welcome to my channel. Today we see the classification of aromatic, anti-aromatic and non-aromatic compounds. To classify the given compound as aromatic, anti-aromatic and non-aromatic, we must know certain conditions. What are the conditions? I take here aromatic compounds, aromatic and anti-aromatic and anti-aromatic, aromatic and anti-aromatic. Three conditions are same for both these. First, the compound must be cyclic. Compound must be cyclic. What is called cyclic? Cyclic means a ring structure. That should have a ring structure. It's also same condition, ring structure. It may contain one or two rings or three rings like this. And second condition is here planar. Here also the planar. Planar means you all know that here flat molecule on the same plane, flat molecule. But here, to know whether that is flat molecule or not, here we must know its hybridization. Whether the given organic compound is belonging to Sp2 or Sp hybridization. Sp2, Sp hybridization. And the third one is very important one is here extended conjugation. You can keep here conjugation. Conjugation. It is called conjugation. Conjugation means we can say here resonance. That is called here conjugation. And the fourth one is here. But for the first 3 points in aromatic and anti-aromatic, both these compounds have the same conditions. Fourth one is here 4n plus 2 rule, but here it is 4n rule. It is called as here Huckel rule. 4n plus 2 rule, it is 4n rule. Here n takes value start from 0, 1, 2 like this. But here the n value takes here 1, 2, 3 like this here whole number. Here the pi electron number in the aromatic in the ring here the pi electron number should be equal to what is that here means 2 here 6 10 14 then 18 like this 2 6 10 14 18 like this. Here the pi electron number in the ring, pi electron number in the ring is 4 8 12 16 like that. Pi electron number means the number of pi bonds, odd numbers. That may be 1 3 something like that, 1 3 5 something like that. But here the number of pi bonds even number, that is 2 4 6 etc. These are the conditions. If it is next type, third type is here, it is non-aromatic compound. Non-aromatic compound. So these are the compounds which are not fulfilling these conditions. Out of these here 4 conditions, it may have here 1 or 2 conditions it may satisfy, but it cannot satisfy all the 4 conditions, right? And very important one is here whether these non-aromatic compounds satisfy first 3 points, but those compounds do not satisfy 4n plus 2 rule or 4n rule. They are not satisfying this. That is called here non-aromatic compound. Let me take here some examples of organic compound and find out whether those compounds are belonging to aromatic, then anti-aromatic, non-aromatic like this. First compound we take here, this is the first compound I take this. See, we want to know whether it is aromatic. Now you see it is cyclic, it has a ring. It is also cyclic, but planar. Planar means you all know 1, 2, 3. Here one hydrogen is there. Hydrogen. Here one hydrogen. Here one hydrogen. Here one hydrogen. This is carbon is surrounded by 1, 2, 3. 3 sigma bond and 1 double bond. 3 sigma bond means its hybridization is sp2. Like this, all these carbons have hybridization sp2. Here also sp2. Conjugation, alternate double bond, single bond, double bond, single bond. Here also. Now I come to know whether it obeys 4n plus 2 or 4n rule. 4n plus 2 here means then now you come to that number of pi electron. Number of pi bond should be odd number. You see 1, 2, 3 odd number. Odd number means it must belong to aromatic type. Here I can check 4n plus 2 rule I apply, that's equal to 4n plus 2 is equal to number of pi electron 2, 4, 6, that is 6. That means 4n is equal to 6 minus 2, then n is equal to 4 by 4, that comes equal to 1. So we are getting n value out of these numbers 0, 1, 2, 3, you may get any number. I am getting here 1. So we are getting n is equal to 1. So this compound must belong to aromatic type. Next one I can take one more compound. Here I am taking this, you see, lone pair. I take it as lone pair. Now we want to know whether this lone pair is involved in conjugation or not. If it is not involved in the conjugation, you should not take these two lone pair, this lone pair into account. We no need to take this lone pair of electron into account. We want to know whether it is cyclic, flat, right? It is alternate double bond. It is here flat, here one hydrogen, here one hydrogen, here one hydrogen, here one hydrogen, here one hydrogen. Nitrogen is surrounded by 3 bonds here, this lone pair. So here 3 it is. So it is here planar, flat molecule. Conjugation, yes, double bond, single bond, double bond, single bond. I want to know whether it obeys this or this. Number of, you see, double bond 1, 2, 3. It is even number. Even number means 6 pi electron. So 6 pi electron. 6 pi electron here means this is aromatic. Then we can go for here one more compound. Suppose I take here quinoline compound. It is named as here quinoline. Here this is the compound I take. Here you see it has here 2 rings. It has here 2 rings, but it is here cyclic, planar. Yes, it is planar here. It is Sp2 hybridization. Here, all these are Sp2. Here you see double bond, single bond, double bond. It is here one hydrogen, 1, 2, 3. It is Sp2 like this. Here all these are Sp2. No need to find out this. Conjugation, yes, double bond, single bond, double bond, single bond. Conjugation is 4n plus 2 or 4n. You see in both these here the number of pi electron, these 2 electron, that is lone pair, is not involved in the conjugation. So you don't count this. Now you come to this here 4n plus 2 or this. To know this here number of pi bonds, how many pi bonds it has? 1, 2, 3, 4, 5. 5 bonds means it is number of pi bond is equal to odd number. Odd number means it must be aromatic. So it is aromatic. It is aromatic, but it is aromatic having how many pi electron? 2, 4, 6, 8, 10. So here 10 number of pi electron is equal to 10 pi electrons. Right, that's all about the 3 important compounds for aromatic. I go for here one more compound. What is the one more compound? Suppose I take here, you see, I take here I take a compound. What compound I take here? Pyrrole. Pyrrole is a compound I take. This is named as the pyrrole compound. This is here pyrrole. Now in the ring, you see, in the ring, is it a ring compound? Yes, it is a ring compound. Now you see it's a ring compound. Right. Is it planar? Yes, it is Sp2, all these are Sp2 hybridization. Here also 1, 2, 3 hydrogen, only one hydrogen, here hydrogen, here hydrogen, here hydrogen. It is Sp2 hybridization. If it is Sp2 hybridization, that is here planar. It is also conjugation, yes, double bond, single bond. It also involves the 2 electron position inside the ring, the 5-member ring. It is involving in the bonding. So conjugation is there. It obeys which rule? Now you come to the odd electron. Number of pi electron include this including this, because it is involved in the resonance. So total number of pi electron, how many pi electron? Number of pi bonds 1, 2, 3. 3 pi bonds here means it is odd number. Odd number means you can go for it is aromatic. Number of pi electron 2, 4, 6. Number of pi electron 2, 4, 6. That means definitely it obeys here 4n plus 2. That is called Huckel rule. 4n plus 2. That is equal to 6. So 4n is equal to 6 minus 2, that is n is equal to 4 by 4, that's equal to 1. This is n. N comes equal to 1 means then it is aromatic. This is also called as here aromatic, right? Next one is here, I can go for here one more compound. It is called thiophene. It is named as here thiophene. Thiophene is a compound I take. This. It is called as here thiophene. This is. We want to know whether it belongs to aromatic or not, right? To know this here it belongs to aromatic or not, what we can do here, go for cyclic. It is cyclic, first one. Second one is it here planar or not? Yes, it is here hydrogen 1 2 3. It is sp2, all these are sp2, right? No problem. Then you come to conjugation. Conjugation is there, right? Alternate double bond, single bond, double bond, single bond. So how many pi electron? You see this is the one lone pair electron which involves in the conjugation. So here 1 pi electron, 2 3, here these 3 bonds. 3 bonds here means it is odd number. Number of bonds odd number. So 3 bonds here means definitely it must be aromatic. Then I write here how many pi electron? 2 4 6. So 6 pi electron. 6 pi electron means it is aromatic. So then already we saw that 4n plus 2 is equal to 6. So n value takes here 1. This is also aromatic. So in this way we can find out whether the given organic compound is belonging to aromatic, aliphatic or something like aromatic, anti-aromatic or non-aromatic compound. One or two more compounds we see for aromatic. Whatsoever aromatic I take here, I take a 7-membered ring. You see what is the ring I take? 7-membered. I take a 7-membered ring. You see 1, here 2, here 3. It has here plus. I want to know whether it is aromatic or not. To know this is aromatic or not, what we can do? It is a ring. First one ring. It is planar. Sp2 hybridization. Here you see 1, 2, 3. Here 1 hydrogen. 1, 2, 3. Here 1 hydrogen. 1, 2, 3. Here hydrogen. Here hydrogen. 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 But here if no plus is there, it has 2 hydrogen. If 1 plus is there, 1 hydrogen is missing, so it has here 1 hydrogen. So how many sigma bond? 1 2 3. So it is sp2 hybridization. Here sp2, all these are sp2. So second one it obeys. Third one conjugation. Yes, conjugation is there. So single bond, here double bond is there. Here it goes a plus moves, so here conjugation is there, right? Then you come to here, it obeys a 4n plus 2 or not here. To know whether it is obeying 4n plus 2, don't go into the formula. You see number of pi bond, odd number. How many? 1 2 3. 3 means 3 pi bond here means how many pi electrons are there? 6 pi electron. So 6 pi electron means it must belong to aromatic. It is aromatic. It is aromatic. So in this way we can find out. Next what we can take here, then a 8-member ring I take. You see 8-member ring I take. What I take? Here 1 double bond, here double bond, here double bond. It has here 2 electron. It has 2 electron. It has 2 electron. Now you see that here first I want to know whether it is cyclic or not. Yes, it is cyclic. Planar. Yes, it is planar. Conjugation. Here these the negative charged electron is also involving in the conjugation. It is involving. It is also involving. But actually before we see this, I take here one more case and let me say whether that belongs to aromatic or anti-aromatic. Suppose I take this is a compound I take. You see. This is a compound I take. I want to know whether it is aromatic or anti-aromatic. To know that here what I need to find out, first it is cyclic, right? It is cyclic. Second one planar. Planar here means here you see here 1 2 3 with here 1 hydrogen, 1 2 3 here with 1 hydrogen, here 1 2 here 1 hydrogen is there. With addition to the hydrogen we have a negative charge. So hybridization is sp2. Here the hybridization is sp2, but here the hybridization is sp3. But sp3. But if this 2 electron present on this carbon involves in the conjugation, involves in the delocalization or involves in the reasoning, that sp3 is becoming sp2. So you can keep this as here sp2. What is the hybridization of this? Sp2, Sp2, Sp2. So it is here planar. Whether conjugation is there? Yes, double bond can enter this. If it enters, then we get a conjugation. Only one I say how it enters. You see, if this one is involving in the conjugation, it enters here. Then how it becomes? Here double bond, it comes here. This electron will go here. Now it is here. This is. It is called conjugation. Then here I have shown. Then next case, if this electron goes here, it moves somewhere. So it is called as conjugation. It is called resonance. So it shows here resonance also. My work is to check whether it obeys 4n plus 2 rule or here 4n rule. I write here how many pi bond electrons, pi electron, here 1. This also involves in the resonance. So here 1 pi bond, here 1 pi bond, totally 4 electron. 4 electron means that comes here odd number, even number of pi bonds. It comes here even number of pi bonds. So if it is even number of pi bonds, it does not obey Huckel rule. It obeys here 4n rule. 4n is equal to 4. So n is equal to 4 by 4. That's equal to 1. So if you are getting 1, then n is equal to 1. So it is not aromatic, but it belongs to anti-aromatic. So it belongs to anti-aromatic. It belongs to anti-aromatic. Now you come to that in the similar way. This also involved, this also involved, but actually here one hydrogen is there, here one hydrogen is there. It is Sp3 hybridization only. When these electrons involved in the resonance, Sp3 hybridization is becoming Sp2 hybridization. This is now you come to this. So if it involves, so it is cyclic, right? It obeys cyclic. Planar, yes, Sp2, 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 it is planar. Conjugation is there, definitely conjugation is there. Then 4n plus 2. Before that, you see total number of pi bond number, odd number, even number. 1, 2, 3. When it comes, it is on pi bond. When it is coming, it is on pi bond. Total number of pi bond, it is 5 pi bonds. 5 pi bonds. So it is here odd number. If it is odd number, definitely it must be aromatic. Aromatic. I write here Huckel rule that 4n plus 2 is equal to 5 into 2, 10 electrons. Right? 4n is equal to 10 minus 2, it is 8. N is equal to 8 by 4, that comes equal to 2. So it belongs to aromatic. Right. Next I can go for here one more example for this. I take here a 7 carbon containing ring. I take, you see this I take. This I take. In this here, it has here one negative sign. If it is negative sign, already I said here it involves in the resonance. If it is involving in the resonance, Sp3 is becoming Sp2 hybridization. Here also Sp2, all these are Sp2. But here I want to find out whether it belongs to aromatic aliphatic. Simple idea. You count the number of pi bonds. 1, 2, 3. If it enters 4 pi bonds mean pi bond number is even number. If the pi bond number is even, how many pi bond? 4 pi bond. Pi bond numbers even. If the pi bond number is even, it is here anti-aromatic. It is anti-aromatic. If it is anti-aromatic, it obeys here 4n rule. That 4n rule is equal to how many pi bond? 4 pi bond. Each pi bond carries 2 electrons. 4 into 2, it is 8 electron. That is n is equal to 8 by 4, that comes equal to 2. So n value is equal to 2. So it is obeying. So it is called anti-aromatic. It is anti-aromatic. One more we see. You see what compound I take? I take this compound. Don't see, it is very easy. You count the total number of pi bond. Here 1, here 1. How many pi bonds are here? 2 pi bonds. So it is even number. Even number of pi bonds. If it is even number of pi bonds, it is anti-aromatic. It is anti-aromatic. That's all about anti-aromatic and aromatic. One more we can go for here, that is called as here pentylene. One more we can go for, that is called as here pentylene. You see how I am taking the pentylene compound. It is like this. This one. Here one. Here. This is. Now how to draw the structure for this? Here 1, it is here I can draw here 1. So here 1, then here 1. This is. Now you count here the total number of here pi bonds 1, 2, 3, 4. 4 means it is even number. If pi bonds number are in even number, then even number of pi bonds. If the pi bond number is even bonds, go for it is anti-aromatic. It is anti-aromatic. Anti-aromatic means it obeys 4n rule. That is 4n is equal to 1, 2, 3, 4. That 4 into 2, 8 electron. That is n value is equal to 8 by 4. That comes equal to 2. So this is this compound pentylene. It is called pentylene. Pentylene is called as here. It is anti-aromatic. Then we can go for here 1 or 2 examples for aromatic non-aromatic compound. That is called non-aromatic compound. I can take this compound here, whether it is aromatic or non-aromatic. So it is first one cyclic is there. We want to check whether it is planar or not. To check whether it is planar or not, you check the hybridization. But here you see no double bond, it is surrounding. So each carbon has here 4 sigma bond. 4 sigma bond means sp3. sp3 hybridization means it is not planar. It is not planar. If it is not planar, that cannot be aromatic or anti-aromatic. It must be here non-aromatic. It is non-aromatic. Then we can go for here this compound. This is here I put and here 1 plus. I want to find out whether it is aromatic or anti-aromatic or non-aromatic. See here it is sp2, here sp2 because double bond surrounding, but here sp3. If it is sp3, that is not a planar. It is not planar. It is not planar. It cannot be neither aromatic nor anti-aromatic, but it is non-aromatic. It is non-aromatic. Something like that. Now I take here one more compound. Suppose I take this is a compound. This is now it is one free radical. How many pi bonds are there? You include this as pi bond electron. Here 2, here 1, 3 pi electron. If it is 3 pi electron number is odd number. If pi electron number comes as odd number, it is non-aromatic. Pi electron number comes on number, it is aromatic. This is. Now I take this compound. One more compound I take. This one is. Here I take here this. It belongs to what type of organic compound? Whether it is belonging to aromatic, anti-aromatic or non-aromatic, means it is cyclic. But you see this is carbon which is not surrounded by any double bond. So here 1 nitrogen, here 1 nitrogen. This is sp3. If it is sp3, it is a non-planar. It is non-planar. If it is planar, then only it becomes either aromatic or anti-aromatic. It is non-planar means it is here non-aromatic. It is here non-aromatic. 1 or 2 more compounds, we see this. These are the examples for aromatic, anti-aromatic, and then here non-aromatic. Some more compounds here. You see what I take this. You come to this compound. It is called aniline. It is an aniline. What this aniline means? What this aniline here? It is 18 carbon containing aniline. It is 18 carbon containing aniline means you have to count like this: 1, 2, 3, 4, 5, 6. Aniline is a name given to organic compounds which contains monocyclic ring. It is containing monocyclic ring without any substitution. It is monocyclic ring. Even it is also aniline only. Then I take this is aniline only. Here I take one more compound. It is aniline only. If I take this is aniline only. Something like that. It is aniline only. This is aniline only. These are the organic compounds which are monocyclic. And they have here conjugation bond, double bond, single bond, double bond, single bond. It is called 18 aniline mean this is an aniline compound which contains 18 number of carbon atom as well as then 18 pi electron. If the number of pi electron is equal to 18, but here seeing this, all these carbon atoms are sp2. sp2 means it is cyclic, it is planar. Here conjugation is there, everything is okay, extended conjugation, everything is okay. Is it not here? Now we can go for here counting. Here how many pi bond electrons are the pi bond are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 means it is odd number of pi bonds. If the odd number of pi bonds, it belongs to aromatic. When you come to that here, 14 carbon containing aniline. Here also, but here what I have written, no internal strain of hydrogen atom. Here hydrogen is there, one hydrogen, here one hydrogen, here one hydrogen, hydrogen. Because of this hydrogen present at the center portion, but this molecule is spacious. If it is spacious, we don't get here any strain, we don't get here any repulsion. So this compound is stable. Now we come to this here also no internal strain. So here aniline which contains 14 number of carbon, it is 14 aniline, no internal strain. If it is not having any internal strain, count the number of electrons. 1, 2, 3, 4, 5, 6, 7. 7 means it is 7 pi bonds. 7 pi bonds means it is odd number. Odd number means it belongs to aromatic. Now we come to this, it is aniline. How many carbon atoms it has here? 12 carbon atoms. But here one hydrogen is there, here one hydrogen is there, here one hydrogen is there, but this is not spacious. So these 3 hydrogens are very close together. 3 hydrogens are very close together. It has here internal strain. Reflection is there. That is called steric hindrance. Reflection is there. Because of this reflection, this molecule, even though it seems to be planar, sp2 hybridization only, this molecule, because of this repulsion, it is going from planar to non-planar. It is not planar. If it is not planar, then it is non-aromatic. If it is planar, either it is aromatic or anti-aromatic. So it is non-aromatic. Here you come to this, it is 10 aniline. Here also internal strain is there. If internal strain is there, you don't bother about this here, it is non-planar. If internal strain is there, it is non-planar. If it is non-planar, this is non-aromatic. That's all about this. Now we come to, it is called azulene. Azulene, it's a compound which don't have here 6-membered ring. It's a compound in which here 2 rings are fused. One is here 7 carbon containing ring, another one is a 5 carbon containing ring. This compound here also, to know whether it belongs to what type, you count the number of pi bonds. 1, 2, 3, 4, 5. 5 means 5 pi bonds. 5 means it is even odd number. If it is odd number of pi bonds, so go for it is aromatic. If it is even number, you can go for that is this. So these are the ways to find out whether the given organic compound is belonging to aromatic, anti-aromatic, or it is non-aromatic. Thanks for watching my video.